you're gonna be graded. So the first part is tutorial participation marks. This starts today. Okay, so participation marks is a highlight here. It's not called attendance marks, so it's not for attendance. Okay, it's not that, oh, I showed up to tutorial, then I get the mark. It doesn't work like that. You have to show up and you have to be active in tutorial. What's active? Well, what's active? You can ask questions. So some of you ask me questions. You can answer questions. For example, when I ask you, oh, which program are you from? You answered me. That's answering questions. You can have your camera on. Again, this is not mandatory, but I would prefer you have your camera on so that I don't feel like I'm talking to a wall. Not wall, I'm talking to my laptop like I'm crazy. And you should use your mic to ask or answer questions. For this tutorial specifically, you don't have to do that, but starting from the next one, I would say let's all use mic. There is a reason because we won't have that much time to wait for you to type everything out. Because when you ask math questions, I would prefer you have your mic on and talk to each other. That's what we're aiming for. I want you to be nice and respectful to each other. I think this is what I don't have to emphasize. So be nice, be respectful to each other and to me as well. So we'll respect each other, we'll be nice to each other. Next part is tutorial presentation. This is 15%, so I suppose everyone's really curious about this. So how it's gonna work is each tutorial we have 2 hours. You probably know this already. So 2 hours, we might have a break in between, which is like 10 minutes. So we'll have 110 minutes left. During those 110 minutes, we will have you guys present. And I was told that each week we should have 6 presentations. So 6 presentations, and usually, why is it not doing what I wanted to do? Okay, so we will have 6 presentations, and they said usually the presentation takes 20 minutes long. Like not as you actually gonna present for 20 minutes. It's like the whole process of one presentation, including discussion, questions, answers. Those will take around 20 minutes long. So we won't have enough time if you keep typing up your answer. So I would prefer you have your mic on and ask each other questions. And that is why we're recording the tutorial so that I know who asked questions, who answered questions, and so on. That's the first thing. We'll have 6 presentations, and I will tell you who's gonna present which question at the beginning of each tutorial. So let's say at 11 o'clock you come, and we'll type them up. Oh, who's gonna present which question? So the thing is, you have to show up in all tutorials. Otherwise, you might lose your presentation marks as well. Okay, so it's not just participation marks anymore. If I say, oh, you're presenting today, but you're not here, and you cannot provide a valid reason, then you will get 0 for the presentation as well. Okay? Does that make sense? Any questions so far? So I was told that you will not know, well, we have multiple times to present. We'll reach there. We'll reach there. So we don't get a head up or anything on what question we'll be presenting. Yes, you will not know beforehand. That's what I was told, that we don't let you know before the tutorial. So we will have the same question to present. So each one of you will present 1 question. That's why we have 6 presentations. So it's 6 different questions. Not the same thing we go over it 6 times. Can we get a week before so we can prepare? No, that's not how it works. You can only know it on the day and at the beginning of the tutorial. Those questions are from homework, yes. Exactly. So basically, I'll talk about here. So basically your homework, if you check the first one, you have 8 questions. So the 8 questions, 6 of them will be presented and 2 of them will be graded. So the 2 questions that are not presented during tutorial will be marked unquote mark. So those 2 questions every every week, those are the 15% of your mark, and the lowest 2 will be dropped for homework, not presentation. There is no lowest 2 drop for presentation because we don't have enough time for everyone. Okay, so far here, do we have any other question? Oh, the Murph graded as sweet as your voice. We'll talk about how I'm gonna grade you in a moment. Any question before I talk about how you will be graded? Is the homework submit already? Yes. So every week you will submit your homework on Thursday and you will present your homework on Friday. Will you post the notes after tutorial? So here is the thing. I'm not gonna teach in tutorial. There is no teaching at all. It's full presentation. The whole tutorial will be just your presentations. So there is no notes at all. Yeah, because they are just all presentations. We don't have any notes because I'm not teaching. I wish the homework was due at 11 p.m. instead of a.m. I actually talked about this with the professor. Um, I told him, I was like, 11 a.m. is kind of a weird time, cause like usually you either have a due at midnight or you have a due at noon. 11, it's just a weird time to do, and and he's like, he want us to have a whole day to have a look at your. He want us to have a whole day to have a look at your solution and decide who's gonna present. And also, he wants you to and he won't have time for people with accessibility center. So if they get extra time, they can have the extra day. Okay, and next question, let me check. Can we change our solution before presentation? Like if we find something wrong? Yeah, you can do that. So your solution does not have to be 100% like the solution you submitted on Qualmark. Let's say if after the deadline you find that, oh, I can my solution can be better if I rewrite it. I like this. Go ahead. That's totally fine. If we submit but find something to fix before tutorial, yeah, you can totally do that. And if you find that, you should do that. You should definitely do that. Will we get feedback from homework before we present, or are we just doing that? You're not gonna get any feedback before the homework. Um, there's not enough time for us to grade it. Basically, after summit, there is only one day till presentation, so no feedback. Okay. But the thing is, since I'm choosing who's presenting, I'll definitely have a look at your solution before you present. And I'm not gonna pick you if I think your solution is horrible. Okay? So I'm not gonna do that. So I will have a look at your solution, and if I think it's relatively good, I'll pick you. If I think it's horrible, you're not gonna get picked. Yeah, you need to share your screen. That's what I'm gonna do for the next part. Okay, so you don't have to worry about that part. You don't have to worry that, oh, what if my solution is completely wrong. It's not gonna be completely wrong if I pick you to present. Okay. Um. Another thing is this is gonna be different if you miss your presentation. Because if I called you to present today, but you're not here, then you either get a 0 on the presentation or you present next week with a valid reason. So if you cannot present this week, I picked you, you cannot present, then I'll let you present next week. And the next week, I cannot guarantee your homework is gonna be relatively good. So make sure you are here so that this doesn't happen. If we know we can't come to tutorial for some reason, we let you know beforehand. Yes, you should definitely email me so that I'll not pick you. Because once we made the decision, I called you, you're not here, then I have to look over other people's solution and pick someone else. That's gonna be extra work and waste extra time. So don't do that. If you can't come, you should email me. Definitely email me beforehand. So I'm not gonna pick you. It's better for me, better for everyone, and better for you as well. Okay. So any other question before I talk about how you will be graded for presentation? So seems like we're good. Then now let's talk about how you'll be graded. So you'll be marked out of 4. How to grade my question if I'm not the one to present? Then you will not be graded for that question. So we'll only grade the 2 questions that are not presented during tutorial. Anyway, you will be marked out of 4. Um, what you should do is you should have a, a solution written down or typed out already. So do not try to write your solution during your presentation. That's not how it works because that's gonna waste a lot of time. So you should have a clearly written or typed out solution already. I'm not gonna grade you based on how nice your writing are. As long as it's readable for everyone, then it's okay. Okay, so as long as it's clear, it's readable for everyone, um, that's fine. How to grade the tutorial process? I thought we talked about this already. So as long as you're active, being active includes the following. Okay, as long as you're active, you will get full mark. For as long as you're active in all tutorials, you will get full mark for participation marks. So you should ask questions, answer questions, blah 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 blah. Anyway, and then if I call you out, I said, oh, you're presenting, then I'll let you share your screen. So what you're gonna do is you're gonna share everyone your solution on the screen, and then you'll go over your solution and explain your solution to the whole class. So you'll tell us why you're doing this step. Okay, what's your thinking process, and what does this lead us to? Okay, all such things. So that's gonna be your presentation here. That's the main body of your presentation. After your presentation, you should ask everyone, is there any question or comments? Okay, so after presentation, we will have a discussion, which is where everyone else asks you questions or comment on your presentation. Um, yeah, and once everyone else is done, I will ask you additional questions, and you need to answer my additional questions, and then I'll make some comments. And at the end of the tutorial, probably not right after, but on the day. So every Friday, if you're presenting, you will see your marks on Quarkus. Okay, so you will see how you're doing in the presentation. And the presentation is being marked based on this rubric. So if it is correct, real written mathematics, you'll get 4. If it's good, but there are some mathematical errors or some writing errors that needs addressing, or you cannot explain something, you might get 3 or 3.5 because we are allowed to give you 0.5. If your solution has good intuition, but there are serious logic flaws, then you'll get 2. If your proof does not make sense at all, but I see you have some work here, I'll give you 1. If there is nothing, I'll give you 0. We'll get there, we'll get there. Okay. So this is how you'll be marked. Okay? And I can say that if I picked you, then you'll definitely not get to 0 or 1. So the worst mark you can get is probably 2 if you are being picked. But yeah. And if you are not happy with your mark, okay, so let's say I picked you to present, but your presentation didn't go well, your proof is not good. Let's say you get a 2 or you got a 2.5 and you're like, oh, how can I improve? There are improvements you can do. Okay, so if your solution is really bad, okay, you can submit a corrected version to me. So you're not gonna present you're not gonna present the same question again. Instead, you can write a better solution and submit that to me, and then I will mark you based on your corrected version. But the highest mark you can get is 3 out of 4. Does that make sense? So if you do this, the highest mark you can get is 3. Okay? And since someone were asking how many times you're gonna present, so our aim is we will let everyone present twice throughout the semester. And if everyone has presented twice, I will ask you if any one of you wanna volunteer to present. So this is how it works. If you presented twice, then your presentation marks, this 15% will be the average of the 2 presentations. However, if you present it 3 times, then your presentation marks will be the average of the higher 2 presentations. So if you did really, really bad and you wanna improve your presentation marks, once everyone's done twice, you should volunteer to present again. Does that make sense? To get a better mark. So this is like if we have time. But what if all of us want to present 3 times? I don't think that's gonna happen because I think most of you will be happy with your marks. But this is what I'm gonna say is, well, if a lot of people wanna do, then it's first come first serve. There's no other way. I'm not gonna say, oh, I like you more, so I'll let you present, and it's not gonna happen. It's first come first serve. But here is why I'm saying it's bad that we have a lot of students here, because the more students we have, the less chance you'll have to present again. Like right now we have 30 students, and from next week till the end of the semester we have exactly 60 presentations. So that's everyone present twice if we keep the number 30, which is bad. Which is bad for you. Like for me, I don't care, but for you, this is bad. So, I'm not saying some of you should drop. I'm saying if you will you email everyone? No, you will know at the beginning of the tutorial, so there's no email or anything. It's just at the beginning of the tutorial, you know which question you are presenting, or if you are presenting at all. This is why I say that if check the other tutorial, if the time works for you, then some of you should definitely switch to the other tutorials. The tutorial that has less students, because that can get you a chance to present again if you are not happy with your mark. Does that make sense? You mean the third time presentation? No, the third time is first come, first serve. So at the beginning of the presentation, if we have the third time, whoever put in the chat, that's gonna be that's gonna be who presenting. So there's no email involved either. Okay, so check the tutorial time. If the other time works for you, I think some of you should switch to the other tutorial. You don't have to worry about your participation marks for today, because if you're switching to the other tutorial, I'll let Motasen know that you participated in the first tutorial, so you won't lose any mark. So that's why I'm saying it's better that we have less students so that you can present a third time. And homework, 15%. Again, each week you have 8 questions. This is not gonna change. And then 6 of them will be presented in tutorial. The other 2 questions will be marked. I think some of you were curious about who's gonna mark your question. We're taking turns to mark your questions. So, for example, your first assignment will be marked by the other TA, and the second one will be marked by me, and so on. So we're taking turns to mark your questions, so it's fair for everyone. So because we're really trying to be consistent and fair for everyone. So me and the other TA, we're pretty close friends, so we kind of discussed about this already. All right, and the lowest 2 homework will be dropped. Now, any other question? Can we ask for remark on homework? Yes, you can. So, for example, Mortensen marked the first one, and you're not happy about the mark, then you should email him. And if I mark the homework, and you think you deserve more marks, then you should email me. So it depends who's marking the homework. You should email the marker. Mo is a really nice person, so I don't think I will know which TA to mark. Oh, Motesten is marking all the odd assessment, not just homework, for quiz as well. So all the odds assessment is him, all the even assessment is me. So quiz 2 and all the even homework. Then, Helen, Chester, is this all clear for you? Let me see how many of you are here. 27. I thought I emailed everyone and make sure everyone show up today, but seems like some of you don't care. Okay. All right. If it's all good, let's take a break. Let's take a break. What do I do with the break? Is the third presentation mandatory? Yes, we'll have some people present. I'm pretty sure people will volunteer if they don't have perfect. The 15%. I'm not gonna force any one of you to present a third time, but I'm pretty sure people will volunteer. So it's very, very, can we choose which question to present in third time? Yeah, you can choose. Again, first come, first serve. So whoever typed the question in the chat, then you're gonna present that. That's gonna be how it works. All right, let's have a 10-minute break. So 10-minute break, and we'll come back and do some real analysis. Okay. I feel like I should give you a copy of the thing so it's easier. Just give me a moment. Let me send this to. Where did it go? Oh, I see. There we go. So I left it in the chat. It's still uploading because it's quite big. There's some pictures in there. You guys see the file? You can download it. It's probably gonna be hard for you to print it out because I got this background. But I guess you can just write on paper as well. Do you guys get it? Anyone not see the file? Got it? Okay, cool. We'll do some questions. Hopefully we can do the first 3 questions. 1, 2, 3. Yeah. Third one is really long. The fourth one, I don't think we'll do it because you guys haven't covered this yet. Did you guys do a dance? Q is dance in R in lecture, or you didn't even attend the lecture? Anyone know if you guys did rational numbers is dance in real numbers? You did? Understand. Oh, okay. What about did he do not just rational numbers like other sets dance in R? Did he do that? No, mostly rationals and descartes. So we're not gonna do question 4. I'll leave it to for you after you finish this part. Like you can probably try it next week. And he touched on bounds. Well, then he's doing pretty slow though, because your homework involves like Superman, Infinite. Huh, interesting. That's okay. We'll spend quite a lot of time on least upper bound and something like this. Yeah, we'll do that. So hopefully that can help you understand them better. So let's talk about the first. He said, do the homework on Monday. Cool. That's okay. It seems like I'm ahead of, not really ahead, probably a little bit ahead of him. That's okay. Hopefully, with my explanation, you can try the problems yourself. So, the first thing in a red box, it's called axiom of completeness. This is saying that every non-empty set of real numbers. So non-empty set of real numbers means, well, you have something in the set, it's not empty. Okay, so every non-empty set of real numbers that is bounded above has at least upper bound. What is bounded above? Bounded above means that, so let's say if your set is A, okay, let's say this is your set A, and A is not empty. Okay, bounded above means that for all A in A is less than or equal to another number M. Okay, so where m is a real number. So this is bounded above. Which means every single number in your set A is less or equal to something. So you have an upper bound. So that's bounded above, which means you have an upper bound. So this is saying that every set of real number, every non-empty set of real number that is bounded above, you would have at least upper bound. So bounded above is telling you you have an upper bound, but now they're saying you have a least upper bound, which means it's a smallest upper bound. Okay? So this is axiom of completeness. There's not much to do because it's quite straightforward. And here is the definition of bounded above and bounded below. I talked about bounded above, which means you have a upper bound. Bounded below means that you have a lower bound. So that means for all, so for every a in A, you would have a number L in R such that L is less than or equal to all the A in A. So if you are having problem understanding this, think about functions. Like in functions, we also have bounded above or bounded below. It's basically the same idea, except now we have sets. Any questions so far? Is this clear? I had a look at your homework. It's mostly definition unwinding, so you should know the definition quite well in order to do them. Okay, so whenever they say, oh, it's bounded above, then you know that, well, there exists number such that all the number in A is lesser or equal to this number, so you have an upper bound, and so on. Okay, so make sure you know how to use the definition. And now here comes our really, really important definition, which is called the least upper bound. What is the least upper bound? It has to satisfy two conditions. So let's, oh, why is it? Hold on, let me fix this. So let's put a star here because it's quite important. We use it all the time. So a real number S is the least upper bound for a set A if it meets the following two criteria. So if they ask you to prove something is a least upper bound, then you need to prove the following two things. The first is it has to be an upper bound. Okay, in order to be a least upper bound, it has to be an upper bound. Okay, so that's the first thing. It has to be an upper bound. When you try to prove it, what are you trying to do? So you're trying to, so for proof, you are trying to prove that S is greater than or equal to A for all A in the set A. Okay, when you try to prove it's the upper bound, this is what you're trying to show. And the second one says that if B is any upper bound for A, then S has to be smaller than or equal to B, which means the second one you're trying to show S is the smallest upper bound. Well, two conditions. One is it has to be an upper bound. Second is it has to be the least upper bound or smallest upper bound. So to prove that, you just let B be an upper bound and you show that S is less or equal to B. This is how you prove it. So proof. And the least upper bound also has another name, which is called the supremum of the set. So this is what you should know as well. Supremum of A means that it's the least upper bound, and we write it as sub A. Okay, we write it as S a sub A. And corresponding to this, since we have the least upper bound, we also have the greatest lower bound. So it's defined in a similar way. So the greatest lower bound is called the infinite of A. So two conditions again. So two conditions, it has to be a lower bound. Which means that, what do we call it? Let's call it L because it's lower. So which means L has to be less than or equal to A for all A in A. And it has to be the greatest lower bound, which means that if B is any lower bound for A, then your L will be greater than or equal to B. I'm not sure if this is clear for you to read. That's not what I wanted to do. Well, I could change color. Maybe this is better. Okay, so that's infinite. Mostly we'll talk about supremum and infinite, and this is denoted by inf A. So one is sub A, one is inf A. Any questions so far? Do you understand the least upper bound and greatest lower bound? Yes, okay, cool, nice. Now we have another two definitions. One is called the minimum, the other one is called the maximum. So minimum has a maximum. Let's say maximum first. So let's read the definition. A real number A naught is a maximum of the set if, okay, if this is important, if it is an element of A and A naught is greater than or equal to A for all A. So if we have this condition only, then it's called an upper bound. But in order to be the maximum, you also need to be an element of A. Does that make sense? The difference between upper bound and maximum? So in order to be maximum, you also need to be an element of A. But for upper bound, you don't have to be. So sometimes your least upper bound and maximum might be the same number, while other times they're not the same number. Question. Any question? You guys lost already? Seems like some of you are quiet. All good. Okay, cool. Cool. Okay, so that's the main difference. Okay, for minimum as well, the thing is you need to be in A, okay, in order to be minimum. So if you only have this condition, then it's a lower bound. But with this condition together, that makes it a minimum. So to let you check the difference between minimum and maximum, let's look at a number line. So here is a number line, and I'm telling you my set A is everything in between here. So let's say this is my set A. Okay? This is my set A. Then, can someone tell me if I have a maximum? Do I have a maximum? Let's call this A and call this B. Do I have a maximum? Maybe I can make it lighter. About the same. No, okay, no maximum, that's correct. We don't have a maximum. Do we have minimum in this case? That's correct. We don't have minimum either. Okay. What about do I do I have an upper bound? You will not have a maximum or minimum because A and B don't belong to A. That's correct. Because well, think about this is not in A. What is the number that's the greatest in around here? There's no the greatest because like what is let's say if this is one, what is a number that's smaller than one but greater than all the other numbers? The main reason you don't have one is because Q is dense in R because there always exists a rational number in between. So there's no such number that's less than one but greater than all the other numbers. And we just don't exist such number. However, if B is in A, which is what I'm gonna do the next, then you would have a maximum. So let's say this is A, this is B. Let's call it B. Then what is my maximum here? Okay, we have a maximum is B. Minimum? What's my minimum? A. Okay, cool. All right. My next question is, do I have upper bound for A? And how many do I have? Any upper bound at all? Yes, infinitely many, that's correct. Okay, so everything starting from here and after, they're all upper bounds for A. Okay, similarly, we also have infinitely many minimum, I mean, not minimum, lower bounds. Okay, so those are all lower bounds for A. And similarly for B as well. Okay, those are all the upper bounds and those are all the lower bounds. Now, the question is, what's my supremum of A? What's my supremum of A? And what's my infimum of B? Similarly, what's my supremum of B and infimum of B? Is no supremum for A? Yes, that's correct. The supremum of A is B. So this is my supremum of A. And my infimum of A would be A. Okay, so this is my because well B is the, the smallest upper bound I can get. And similarly for B as well, so this is the same for B. And the thing is you can see that for set B, your maximum and supremum are the same, minimum and infimum are the same, but for set A, it's different. Do we have any question for this? This is just trying to help you to understand the difference and what do they mean. So, upper bound can be in set A. That's correct. It doesn't have to be in there, but it can be there. Okay, if this makes sense, let's try an example. Oops, we have a lemma to cover. Let's do the lemma first. So lemma 1.3.7, assume S is an upper bound for a set A, which is a subset of real numbers. Then the supremum of A, then S equals to this. So S is a supremum of A if and only if for every choice of epsilon greater than 0, there exists an element A in A satisfying S minus epsilon is less than A. Sounds really confusing, but not that hard. Because let's use a graph again. Oh, this is too big. Okay, here is a graph. So this is saying that S is an upper bound. So S is somewhere here. So let's say this is my S. Okay, then S is an upper bound of A, right? Does that make sense so far? And they're saying S equals to supremum of A. So S will be equal to B if and only for every choice of epsilon greater than 0. So epsilon, this is used to represent a small number, a really small positive number. Okay, so this is usually used to represent a small positive number. So there exists a positive number, okay? So for every positive number, there exists an element A in A, so there exists an element somewhere in here satisfying S minus this positive number is less than A. So think about if we move S, we move it to here. So S is B now. Then no matter what number you pick, okay, what positive number you pick, if you use S minus this positive number, okay, no matter what you pick. So let's say epsilon is, let's let it be really small, 0.0001. Okay, even if your epsilon is really small, if you use S minus that, you're gonna get a number that's inside of A. Does that make sense? So for any, no matter how small the number you pick, once you use S minus this number, you always get here. However, if your S is not the supremum of A, let's say if S is here, okay, then you can pick a really small number such that S minus this small number is, let's say here, just like a tiny little bit smaller than this, but it's not in A. Does that make sense? So this guarantees that your S is a supremum of A. So this is lemma 1.3.7. So if we want to prove that B is a supremum of A, should we use the definition or lemma, or both our work? It depends on the question itself. Sometimes the definition will be easier, sometimes lemma will be easier. You need to make the judge yourself. Both would work, but sometimes one is much easier than the other. Okay, so since we talked about everything you need so far, so let's try example 1. I'll give you some time to think about it because it's mainly just definition unwinding, and I hope you can solve it yourself. But before that, I will I will talk about what you need to do. Okay, so let's read the question together. I'll talk about what you need to do, and then you'll try it yourself. So let's read it together. It says A is a subset and it's bounded above. Okay, it's bounded above. They didn't tell you what's the bound, the upper bound or anything. They just tell you it's bounded above. Let C be a real number. Define the set C plus A by the following. So C plus A is C plus A where A is in A. They want you to show that the supremum of C plus A equals to C plus the supremum of A. So what are they trying to let you show? They're asking you to show this is a supremum. Okay? And there are two ways you can do that. You can either use a definition or you use this. I think the definition is simpler. So using the definition, you need to show two things. I'll write it here and I'll let you do it. So first of all, you need to show that C plus the supremum of A is an upper bound. Is an upper bound of C plus A. Okay, and then the second, you need to show C plus supremum of A is the least upper bound. And we talked about what you need to do exactly to prove those two. Okay, if you forgot about this already, you go back to here and look at what I told you, what you need to prove. So think about this question. I'll give you 5 minutes and then I'll take it up. Let's get a timer for 5 minutes again. Five minutes, try this question. Time's up, let's take it up. So let's check. First of all, you need to show that it is an upper bound. So you want to show that it's greater than or equal to c plus a for all a in a. So what I'm gonna do is I note that by definition, oops, by definition, of the supremum of a, we know that a is less than or equal to the supremum of a for all a in a. Right? Now what I'm gonna do is I'm just gonna add c on both sides. Then c plus a is gonna be less than or equal to c plus supremum of a for all a in a. You see? Which means what? Which means this is my upper bound already. Which shows that c plus sub a is an upper bound. Of c plus a. Any questions so far? So we're done with the first part already. That's it for the first part. Any question? No? Cool. Cool so far, okay. Now I'm gonna try to show that it's the least upper bound, which means I need to show that for any, let's say for any b in the upper bound of a, I'm just gonna put the dot here, okay? At upper bound of a, then my c plus supremum of a is gonna be less than or equal to b. So this is what I wanna show. So let's suppose that b is an upper bound. Let's see e an upper bound of a. Remember, this is what we want to show. We want to show that c plus supremum of a is less than or equal to b. Okay. Now, since it is an upper bound, oh, not a, sorry, of c plus a. Okay, since it is an upper bound, that means c plus a is less than or equal to b for all a in a. Right? Because it's an upper bound. What does this mean? This implies that that b minus c is also an upper bound. Do you see? What I did is I moved c to the other side. Okay, so this is also an upper bound of a. It's an upper bound a, and because supremum of a is a least upper bound, so this should be less than or equal to d minus c, right? So by definition, of supremum of a, okay, we know that supremum of a is going to be less than or equal to c minus d. And we're almost done. Why? Because if you move this back to the side, you're done. which implies that C plus supremum of A is less than or equal to D. Okay, so C plus supremum of A is the least upper bound of C plus A. We're done. Question? It's basically using the definition and then move things around. It is clear. That's cool. So this question, I chose this one because it uses the definition of supremum a lot, quite a lot, I think. That's why I chose this question. So I want to tell you, well, you can use it definitely. The second question will show you that sometimes using the lemma is easier. For example, the second question. Oh, am I not oh, I see, I see. So the second question, here is my hint already, requires you to use 1.3.7. Let's rate it and then again I'll give you time to work on it. Okay, so this is saying if the supremum of A is strictly less than the supremum of B, they want you to show that there exists an element B in B that is an upper bound of A. Again, the question itself might not be clear enough, so let's draw a diagram. I'll draw you a number line and show you what's going on. So let's say this is supremum of A, and this is supremum of B. Okay, so now they want you to show there exists an element B in B that is an upper bound of A. So think about this. If the supremum of A is here, where can your A be? Your A can be somewhere here, right? So this is where A can be. And where can your B be? B can be anywhere here. So E here. This is where your B can be. And they're saying there exists an element B in B set that is an upper bound. So where your B will be? B will be somewhere here. So somewhere here you would have a B, and this is an upper bound of A. You see? Okay, so you need to find such B or show that it exists. And my hint is you need to use Lemma 1.3.7. Okay, I'll give you another 5 minutes to work on this, and then we'll take it up. Right, let's take it up. So, anyone has any idea of where we would start? How we will start? Anyone has any suggestions? Kind of? Yeah, go on. So, you just lemma. Your situation disjoint or not. Don't really need to discuss cases. You can, but I don't think it's necessary. Let's make my assumption first because well let's see. So let's suppose assume the supremum of A is less than the supremum of B. Okay, then we know that well A is less than or equal to supremum of A, which is less than supremum of B. This is what we know. So my question is, I told you you need to use this, but what are we gonna pick for my epsilon? What do you think pick my epsilon to be will be the best in this situation? So let's let epsilon equals to something. And now supremum of A, think about you're gonna use supremum of B minus this epsilon, right? You wanna use this to minus epsilon, and after you minus it, it has to be less than B. So think about that. Exactly. Let's let it be supremum of B minus supremum of A. So this is going to be your epsilon. So this is the epsilon picking. I know that this is definitely greater than 0 because, well, this is strictly greater than this. Okay, then by lemma, 1.3.7, we know that. Why do we know? Because, well, we know that supremum of B, okay, is so here instead of A we change it to B. So we know that for any choice there exists B in B such that supremum of B minus epsilon is less than B, right? So by lemma we know that there exists B in B such that supremum of B minus epsilon is gonna be less than B. Okay, this is follows directly from the lemma. And what does this tell you? Supremum of B minus this will give you supremum of A, right? So this is telling you supremum of A is less than B. And we know that this is greater than or equal to A, which means what? Which means, well, B is an upper bound of A. We're down 4 lines. Question? So here is what I would say. For questions that ask for existence of something, it will be much easier to use a lemma. Show the supremum is something.